So here I want the equation of the tangent to y equals tangent of x at the point where x equals pi over 4. Okay? Now, you may or may not remember tangent looked like this. It had asymptotes at negative pi over 2 and positive pi over 2. And it went like this. Okay? So pi over 4 was going to be right about here. If you remember, what's the tangent of pi over 4? Anyone remember that?
Wait, tangent of pi over 4?
Mm-hmm.
Okay, so x pi over 4 would be square root of 2 over 2. So square root of 2 over 2 over the square root of 2 over 2?
Yeah.
Which would be 1.
So it'd be 1. Yeah. So here's our point of tangency that we're talking about. It's the point pi over 4, 1. Okay? By the way, guys, this is where they integrate stuff together, where you're having to dredge up things from your memory in trig, you know, with the unit circle, and combine it with stuff with calculus, all right? But that's kind of the beauty of this higher level math, is everything that you were learning in the past is now coming together and mushing, all right? So, we have the tangent here. We want the equation of that tangent line. Okay? So, does anyone remember what the derivative of tangent was?
Secant squared, secant x squared.
Yeah, very good. Secant, we would put the square there just so we know that it's the actual value of secant that's being squared. So secant squared of x. So now we want to find the actual slope of the tangent line. So that's going to be the secant squared of pi over 4. And secant is 1 over
1 over cosine.
cosine. Alright, remember there's only one co in each pair. So sine goes with cosecant, secant goes with cosine. Alright, so 1 over cosine squared of pi over 4. And we already said the cosine of pi over 4
Would be radical 2 over 2.
Yeah, root 2 over 2. So that's what we're squaring. Alright? Well, that's going to be 2/4. And it's 1 over that, so that equals 4 over 2. Which is 2. So our slope for our line here, I know my slope is 2. And by the way, if you can visualize it like we did here, I know this makes sense now. Alright? It makes sense that our slope is positive. Okay? And also now we have the point that we want, so we're going to use our point slope form. Y minus the y coordinate, 1, equals the slope times x minus the x coordinate, which was pi over 4. So don't convert this to like decimals or anything, just leave it as pi. So we'd have y equals 2x minus pi over 2, once we distribute the 2, plus 1. Okay. So our y-intercept down here is negative pi over 2 plus 1. So somewhere around negative 0.5 or so. Okay, but that's our tangent line. Okay. Any questions? Okay. Our last two examples here, and that's all I wanted to do as far as examples, have to do with two different things. One is where is a tangent going to hit the curve a second time? And you might say, well, wait a sec, isn't this a tangent line? I thought tangents only hit the curve at one point. And when you're looking at it within a small range, that is true. However, because we're talking about functions like this cubic that are going to double back on themselves, I could have something that's tangent right here, but then over here it's going to hit that point, hit that function again. Okay? And this is kind of like, you know, think about people racing. Have you ever seen those road rally racers? They're really big over in, I think, like England and Europe and stuff. They're racing through neighborhoods almost, and
Like drag
these
racing
back
or-
roads, and yeah, it's race cars. But they're on like these back roads. It's mud, and some of it's paved, and it's crazy. So let's say you've got a road going like this, and you slide off the road. Well, rather than trying to get right back to the road, you just come back and pick it up over here. That's kind of the idea. You know, here's this tangent line that we went off on. Well, we can hit the function again back over here. So the first thing we need to do, though, is figure out what this tangent line is. Okay, so this is building on what we were just doing with the tangent line. So take a minute here and find, it kind of looks normal, but let's find the equation of the tangent line first from that point 1, 4. Okay? So take your derivative, find your slope, use your point slope form, find the equation of your tangent line. Alright, so we should get here a slope of 4. So obviously my drawing is not accurate, but that's okay. Our slope is 4. What'd you get for the actual equation of the line then?
Y equals 4x.
4x? Just 4x?
Yeah.
Okay. So you do here a y minus 4 equals 4 times x minus 1. Yeah, and you distribute, you get a minus 4. You add 4 to both sides, so your y-intercept 0. Okay, so yeah, y equals 4x is the equation of the tangent line. So now, here's what you need to do, okay? We know this tangent line intersects this curve at this point. The question, though, is, when will it intersect it again? How would we figure that out?
Set them equal to 1.
Yeah, how do you figure out when two things intersect? If they're both equal to y, you can set them equal to each other. 4x equals x cubed plus 2. Or sorry, plus x plus 2. You're finding where the line and the curve will intersect. So now you have 0 equals x cubed minus 3x plus 2. And here's one nice thing. We already know it's going to intersect at 1. So it actually is possible to factor this. Okay? Because just looking at it this way, we're kind of stuck. Alright? But do you remember your synthetic division?
Yeah. Not really.
I know this will factor into, because I know it hits at x equals 1, x minus 1 times something. So here's what I'm going to do. I'm going to take this, I'm going to divide out the x minus 1. So remember, you list your coefficients with your x cubed, then your x squared, then your x, and then your constant. Alright, so the coefficient of x cubed is 1. There's no x squared, so I need to put a 0 in here. And then negative 3, and then 2. And I'm going to be using that 1. Alright? And then if you remember synthetic division, you add straight down. So 1 plus 0 is 1. And then you multiply it over. You're going to multiply the 1 by the 1. Okay? So 1 times 1 is 1. Now we add down, multiply over, add down, multiply over, add down. And I knew I was going to get a 0 here because I knew this was a root. So I should have gotten a remainder of 0. Okay? But the key here is that now I know, since I divided it, this used to be an x cubed. This is now the x squareds, and the x's, and then the constants. So I now know that this is x cubed minus 3x plus 2 divided by the x minus 1. So I know my other set of parentheses. And that's a quadratic, which you can solve by either factoring or by using the quadratic formula, okay? I think factoring is easier. You have x minus 1. This is going to be an x plus 2 and an x minus 1. So I know that my line is going to intersect when x equals 1, which I already knew because this is a tangent line. And by the way, notice the tangent line gave me a multiplicity of 2. So that's a double root. And then my other point is when x is negative 2. Okay? And that's really what we were looking for. We were looking for when will this tangent line meet the curve again?
And you plug it into the original.
And you plug it into the original, yeah. Okay? So a better drawing of this to illustrate would have probably have been something like this. Okay? Here's our point 1, 4. Here's the tangent line. Okay? That has a slope of 4. Over here is when x equaled negative 2.
8.
I'm hitting it again, so yeah, there's a negative 8 when I cube it, plus a negative 2 is a negative 10, plus 2 is a negative 8. So negative 2, negative 8 is that point that we're looking for. Okay? So while it is tangent up here, because of the shapes of these, it is possible to hit the curve again somewhere else. Okay? So, the last one we didn't quite get to, we could introduce it in a minute. Here, we don't know what the point of tangency is, but we know some other point. We want to go from here and hit the tangent.
So would you take the derivative of that and plug in the ladder of it?
You plug in a and a squared.
Oh, okay.
And your slope would then equal your slope formula, 3 minus a squared over 2 minus a.
Oh,
And you can figure out that way. We can talk about that one tomorrow, though,
perfect.
or Monday.
So,
All right, have a great